NASA's James Webb Space Telescope has hardly opened its eyes, and already the universe seems new. The James Webb Telescope has just spotted something in the depths of space, sending shivers down scientists' spines. This enigmatic object, hidden in the vastness of the cosmos, defies all expectations and raises more questions than answers. What could this unsettling discovery reveal about the universe's dark secrets? Is it a clue to a cosmic phenomenon, or is it a sign of something far more ominous? Join us as we unravel the terrifying object the James Webb Telescope just captured, the interstellar intruder. On October 19, 2017, a mysterious object named Oumuamua was spotted racing through our solar system. This object had been journeying through space for over a century before we knew it existed. Although it had passed a significant cosmic milestone back in 1837, it had gone unnoticed by astronomers. Then, Oumuamua traveled through our solar system for many years, but despite its steady speed, it evaded detection by astronomers and telescopes until 2017. That year, Robert Warwick, a scientist at the University of Hawaii, finally noticed something unusual. He observed a faint, elongated streak in the sky, which was captured by the Pan-STARRS 1 telescope. This streak turned out to be a fast-moving object that was like nothing scientists had seen before. Initially, scientists thought Oumuamua might be a comet because of its odd behavior, but as they studied it further, they realized it was actually an asteroid, a small rocky body typically found in the asteroid belt between Mars and Jupiter. However, Oumuamua's rapid departure from the Sun puzzled scientists. It didn't show any signs of outgassing, which usually makes comets accelerate. This led to debates about whether it was an asteroid or a comet. One of the most intriguing features of Oumuamua was its regular brightening and dimming every 7.3 hours. This pattern suggested that it was spinning on its shorter axis. Its high speed implied that Oumuamua was a solid object, more durable and long-lasting than most comets, which tend to be fragile and crumbly. Its dark red color, similar to some moons in the outer solar system, indicated that it had been exposed to cosmic radiation for millions of years, changing its surface over time. As experts delved into the data, they began to question what Oumuamua really was. Some thought it might be a high-tech probe from another world, or even an old alien spacecraft. Others leaned towards simpler ideas, like it being a new kind of comet or asteroid. More cautious theories suggest that Oumuamua could be a piece of a distant planet cast out from another star system during a major disaster. Despite these varied theories, no one has yet agreed on what Oumuamua truly is. Figuring out where it's headed has been challenging since it's already speeding away from the Sun at a sharp angle, leaving our solar system. Current predictions suggest that Oumuamua is heading back into the vastness of interstellar space, where it will continue its solitary journey through the universe. Alien probe or cosmic oddity, the discovery of Oumuamua set off a wave of excitement and debate among astronomers, scientists, and the public alike. This mysterious space object was the first of its kind ever seen, and it quickly became the center of attention. Its odd shape and behavior led to a flurry of theories about where it came from and what it was. Was Oumuamua just another asteroid or comet, or could it be an alien probe sent to explore our solar system? When Oumuamua was first spotted, scientists thought it might be a typical asteroid made of rock. But its strange elongated shape, about 800 meters long and only 80 meters wide, didn't match any known asteroids or comets in our solar system. As more data came in, ideas about Oumuamua began to change. Some scientists proposed that the object might be filled with gas, which could explain its unexpected speed as it moved away from the Sun. Then, an even more astonishing idea emerged. What if Oumuamua wasn't a natural object at all, but a spacecraft from another world? The peculiar features of Oumuamua, especially its unusual acceleration that didn't seem to be caused by gravity, fueled this speculation. Normally, comets speed up as they get closer to the Sun due to gas and dust being expelled. However, no such outgassing was detected from Oumuamua. This led some researchers to consider the possibility that it might be a probe sent by an advanced alien civilization to study Earth. Though this idea may sound like science fiction, it's a thrilling concept for those who believe in the possibility of extraterrestrial life. Dr. Michio Kaku, a renowned theoretical physicist, suggested that Oumuamua could have been ejected from a distant star during a supernova explosion. Meanwhile, billionaire entrepreneur Elon Musk speculated that the object might have formed from the collision and melting of two celestial bodies, giving it its unique shape. Initially, astronomers were excited to find that Oumuamua's path seemed to point toward Vega, the brightest star in the Lyra constellation, known for its debris disk. Calculations suggested that Oumuamua could have traveled around 600,000 years from Vega to reach its current position. However, this theory quickly fell apart when it became clear that Oumuamua's trajectory had changed during its journey. Astronomers believe that before entering our solar system, Oumuamua must have passed near a different star system. Its speed was similar to that of nearby stars, making it likely that Oumuamua had been traveling through the Milky Way for billions of years before it arrived here. An intriguing theory proposes that Oumuamua might be a chunk of nitrogen ice. Researchers Alan Jackson and Stephen Desch from Arizona State University think it could be debris from a Pluto-like object that was blasted into space by a huge collision. For this idea to be correct, Oumuamua would need to be much smaller than we initially thought. However, this nitrogen ice theory is gaining traction because it helps explain both the unusual makeup of Oumuamua and its strange acceleration. Oumuamua's acceleration mystery. When Oumuamua first appeared, it was quickly discovered that it was on a hyperbolic path, a kind of cosmic boomerang. This orbit indicated that the object wasn't from our solar system. It was just passing through and would continue on its way, never to return. Many thought it would drift off into the void of space, disappearing from view forever. But Oumuamua surprised everyone as it approached the sun. It sped up unexpectedly. Normally, gravity from stars and planets speeds up comets and asteroids, but Oumuamua's acceleration was far beyond what could be explained by these forces alone. It was racing along at 54 meters per second, or about 87 kilometers per second, nearly 3 times faster than most comets. This strange acceleration led scientists to rethink their initial guess that Oumuamua was an asteroid. They started to consider whether it could be a comet instead. Comets usually speed up because ice on their surfaces turns into gas as they near the sun, creating thrust and forming a visible tail. However, Oumuamua didn't have a tail or any signs of this gas release. This mystery led researchers to explore other possible explanations. Jennifer Bergner from UC Berkeley and Daryl Seligman from Cornell University came up with an intriguing new theory. They proposed that Oumuamua's odd behavior might be due to outgassing triggered by cosmic radiation beyond our solar system. As Oumuamua traveled through space, cosmic rays could have caused hydrogen trapped in its icy surface to escape when it warmed up near the sun. This hydrogen might have been released with enough force to explain its unusual speed. Their theory, supported by research showing that cosmic rays can break hydrogen from ice, offers a fresh perspective on Oumuamua's mysterious acceleration. Seligman believes that the latest explanation for Oumuamua is simpler and more believable compared to earlier, wilder theories that suggested it might be a piece of hydrogen ice or some strange material. Yet, not all experts are convinced. Harvard scientist Avi Loeb, who once suggested that Oumuamua could be an alien spacecraft, disagrees with this new idea. Loeb argues that Bergner and Seligman might have overestimated the amount of hydrogen in Oumuamua due to a mistake in their temperature calculations. Loeb firmly stands by his belief that Oumuamua might not be a natural object. He explains that calculating the surface temperature of Oumuamua isn't complicated. It involves balancing the heat it gets from the sun with the cooling it loses as it radiates energy away. He also points out that energy spent on ejecting hydrogen atoms from the surface was left out of the thermal model by Bergner and Seligman in their recent study. This oversight, according to Loeb, led to their model overestimating the surface temperature by 9 times. Because of this, the thermal speed of hydrogen gas escaping from Oumuamua is actually 3 times lower than they thought. Loeb further explains why the errors in the comet study's numbers lead to incorrect conclusions. The original model assumed that about a third of the hydrogen atoms were separated from water by cosmic rays. However, the new results suggest that all the hydrogen needs to be separated, which makes the model unrealistic. This is because a completely hydrogen surface would be similar to the hydrogen iceberg idea proposed by Daryl Seligman. Loeb and Tam Hong, an associate professor at the Korea University of Science and Technology, demonstrated that starlight from other stars would quickly destroy pure hydrogen layers. This would prevent them from reaching our solar system like Oumuamua. Additionally, the lower surface temperature further hinders the process of thermal annealing of water ice, which Bergner and Seligman suggested was responsible for releasing molecular hydrogen. With Oumuamua now too far away to study, its true nature and composition might remain a secret. Despite this, Seligman is hopeful that we will soon discover more interstellar objects, giving astronomers fresh chances to explore these cosmic visitors. The next generation of powerful telescopes, expected to be up and running in the next decade, could greatly boost our understanding and help solve the mysteries of interstellar objects. Meanwhile, scientists have stumbled upon another intriguing twist. Oumuamua might not be alone. Recent findings suggest it could be accompanied by another interstellar object. This raises new questions. What is this potential companion? And does it play a role in Oumuamua's unexpected journey through our solar system? Could this discovery mark the start of a new chapter in our cosmic knowledge, or could it hint at something more ominous? Oumuamua's cosmic journey. Some scientists have proposed sending robotic spacecraft equipped with sails to get a closer look at Oumuamua due to its strange behavior and mysterious origins. However, current technology makes this goal unattainable for now. Projects like Breakthrough Starshot are exploring the idea of spacecraft propelled by light that could reach distant stars, but this technology is still in its early stages. Although catching up with Oumuamua is beyond our reach for the moment, its brief visit has given us valuable insights that could help us in future encounters with similar objects. Oumuamua's journey to our solar system might have spanned billions of years, but in cosmic terms, its passage through our solar neighborhood is just a brief moment. The Milky Way galaxy is about 10 billion years old, and Oumuamua might have traveled through up to 20,000 different star systems over its long journey. While this is just a small fraction of the galaxy's estimated 200 billion stars, it suggests that Oumuamua has experienced many cosmic interactions and possibly collected dust and debris from various environments along the way. Some researchers have speculated that Oumuamua might be heading towards the Kuiper Belt, a region of icy bodies beyond Neptune. However, tracking its exact path has been difficult. Scientists use mathematical models and the limited data available to predict its course and potential destinations, but no one has yet pinpointed its precise location or confirmed its future trajectory. One of the most puzzling aspects of Oumuamua is its unusual acceleration. While celestial bodies are generally influenced by gravity, Oumuamua's speed suggests other factors are at play. Planetary astronomer Dr. Michelle Bannister has proposed a few explanations for this strange acceleration. One idea is that Oumuamua might be outgassing, similar to comets. As a comet's icy surface turns directly into gas, it can create thrust, altering the object's speed and rotation as it nears the sun. This theory aligns with the behavior of known comets, where escaping gas carries away dust from the surface. Even though Oumuamua didn't show the usual signs of outgassing, Dr. Bannister suggested that the asteroid might still have particles affecting its speed. This added an extra layer of mystery because astronomers struggled to find the typical signs of outgassing, like cyanogen gas, which is often present in comets. Despite extensive searches, no gas emissions were detected, hinting that Oumuamua might be chemically different from any comet known in our solar system. Researchers even spent over 30 hours observing it with the Spitzer Space Telescope to catch any thermal emissions that could reveal more about its composition. Unfortunately, these efforts didn't yield clear results. The absence of thermal emissions and gas made it even harder to classify Oumuamua. Scientists speculated that it might be more reflective than initially thought if it had characteristics similar to a comet, but these details remain elusive. Reflectivity, or albedo, can give clues about an object's size and composition. And surface features, despite knowing something about Oumuamua, its true nature remains undefined. It continues to be a unique and puzzling visitor from beyond our solar system, challenging our understanding of celestial objects and raising more questions than answers. Some even speculate that Oumuamua might be something extraordinary or potentially dangerous due to its strange movements and the lack of concrete data. Recent theories have even suggested it could be on a collision course with Earth soon, though current evidence does not support these claims. The search for alien probes. On March 9, 2017, about 6 months before Oumuamua's close pass by Earth, a small interstellar meteor, IM-2, made a dramatic entrance into our planet's atmosphere. The discovery was made through data from NASA's Center for Near-Earth Object Studies, CNEOS, Fireball Catalog, which tracks meteors that fall to Earth. It was detected at an altitude of 23 kilometers above the Atlantic Ocean near Portugal. This meteor, which was roughly 3 feet in size, was hurtling through space at an incredible speed of 40 kilometers per second. Scientists also compared the strength of IM-1, which had been observed by U.S. Department of Defense sensors as it burned up over Papua New Guinea in 2014, to IM-2 and other CNEOS objects. While IM-1 and IM-2 didn't have a direct link to Oumuamua, Harvard scientist Avi Loeb found them intriguing. Loeb speculated that an artificial interstellar object might act as a mothership, releasing smaller probes as it passed near Earth. In their preliminary research, Loeb and Sean Kirkpatrick, director of the Pentagon's All-Domain Anomaly Resolution Office, explored this idea. They suggested that these small probes could be expelled from a larger spacecraft by natural forces like solar radiation or gravitational pull. Due to their small size and low sunlight reflection, these dandelion seed probes, as Loeb called them, might be difficult for our telescopes to detect. These tiny probes could approach Earth using advanced technology to slow their descent, potentially landing safely with parachute-like devices. Loeb's theories revolve around the possibility that advanced extraterrestrial civilizations might be interested in studying rocky planets with atmospheres like Earth, Mars, and Venus. He proposed that such civilizations could have launched exploratory probes long before humans ventured into space. If this were the case, these probes might not stay in contact with their mothership and could become lost or inactive over time. Loeb compared this idea to searching through a mailbox for letters from someone who might no longer be alive, suggesting that these probes could continue their mission even if the civilization that created them had vanished. Loeb's suggestion in 2018 that Oumuamua could be an alien spacecraft was met with considerable skepticism from the scientific community. Many researchers argue that his theory lacks solid evidence. A 2021 letter in the journal Astronomy and Astrophysics dismissed the idea of interstellar travel due to the vast cosmic distances involved. The authors concluded that Oumuamua was more likely a naturally occurring object, possibly an unusual rock, rather than an alien probe. Recent research supports the idea that the strange acceleration of Oumuamua, the mysterious object from space, can be explained by natural causes. On March 22, 2023, scientists shared findings suggesting that Oumuamua likely sped up as it traveled through our solar system because it released hydrogen from within its icy surface. This hydrogen release could have mimicked the effect of propulsion, making it seem as if the object was moving unusually. Meanwhile, the Pentagon has intensified its investigation into unexplained aerial phenomena in the U.S. The All-Domain Anomaly Resolution Office, which was established to look into these mysteries, has launched over 360 new probes into reported encounters with unidentified objects involving military personnel. About half of these cases have been traced back to balloons or other known objects, but the rest remain unexplained due to a lack of sufficient details. Now it's time for today's subscriber pick. In the dead of night, Dr. Elena Rivera peered through the screens at the James Webb Space Telescope's latest feed. What she saw sent chills down her spine. The telescope had just captured a horrifying object drifting through the cosmos, a massive dark sphere with a surface that seemed to pulse and shimmer with an eerie, almost living light. James Webb Telescope just captured a terrifying object in space, she whispered, unable to tear her eyes away. The object was unlike anything seen before. Its surface was covered in strange symbols that glowed faintly against the void. Even more unsettling were the brief, flickering bursts of energy that seemed to emanate from it, casting bizarre shadows across the surrounding stars. The team at the observatory was abuzz with theories. Some speculated it was an ancient alien probe, but its mission was long forgotten. Others thought it might be a remnant of a long-lost civilization, drifting aimlessly through the galaxy. As the hours ticked by, the mystery deepened. Dr. Rivera knew one thing for sure. The object's sudden appearance was not a coincidence. Whatever it was, it had a story, and the James Webb Telescope had just unveiled the prologue. Exploring the unknown. To unlock the mysteries of deep space and investigate puzzling objects like Oumuamua, we must enhance our grasp of dark energy and other cosmic phenomena. The idea of dispatching a spacecraft to follow this unusual object is captivating but fraught with challenges. For instance, Oumuamua, which is speeding through space at a staggering rate, will zip past Saturn's orbit in just 2 years, moving at an astonishing speed of 5.5 astronomical units per year. This mission would be unprecedented in human history. Our fastest spacecraft falls short of such speeds, raising the question: what kind of vessel could complete such a quest? Should we employ advanced technologies like solar sails or venture into speculative ideas like wormholes? While tackling these technological hurdles, it's essential to remember that humans have a unique passion for space exploration. Unlike most animals on Earth, whether birds, reptiles, or fish, that rarely think beyond their immediate environment, humans are driven to explore the unknown. Even among intelligent species like whales, the concept of space travel or extraterrestrial communication seems out of reach. This sparks a thought-provoking question. If Earth's intelligent species largely overlook the vastness of space, what might this suggest about extraterrestrial civilizations? Could they also be blissfully unaware of the larger universe, much like most creatures on our planet? Considering the universe's 14-billion-year saga and the fact that humanity has only had the tools to detect alien signals for just over a century, we might be only scratching the surface of what's out there. Think of all the radio waves, messages, and signals we've launched into the cosmos as akin to tossing a single grain of sand towards the peak of a mountain, hoping it might hit a bird perched on top. Yet scientists cling to the hope that extraterrestrial civilizations might exist, leading to the creation of the Fermi paradox. This paradox brings to light the strange mismatch between the high likelihood of other civilizations existing and our total lack of evidence for them. With over 400 billion stars in our galaxy alone, many of which likely host planets capable of supporting life, it seems reasonable to assume that intelligent beings could be out there and have developed advanced space travel technologies. Given that many stars are billions of years older than our own sun, these civilizations should theoretically be far more advanced than we are. However, we haven't uncovered any solid proof of their existence. The Fermi paradox underscores that while extraterrestrials should exist and be able to travel between stars, we haven't made clear contact with them. This has led some to suggest that our search might be futile and that resources should be redirected. Critics argue that unless extraterrestrials reveal themselves, continuing to fund research like the Search for Extraterrestrial Intelligence, SETI, may be unjustified. The paradox is named after physicist Enrico Fermi, who famously asked, "Where is everybody?" during a casual conversation with fellow scientists. His question is often misinterpreted as, if extraterrestrials are out there, why haven't they come to visit? Despite our technological advancements and a deeper understanding of the cosmos, we still lack a satisfactory answer. Even though scientists have improved their estimates of cosmic quantities, such as the number of galaxies, stars, and potentially habitable planets, there remain immense gaps in our knowledge. For instance, while we can hypothesize about the likelihood of life emerging on Earth-like planets or evolving into intelligent beings, we lack solid scientific data to back these projections. The existence of life on Earth does not guarantee it will appear elsewhere. With only Earth as a reference, making broad assumptions about life's probability across the universe is largely speculative. Scientists have been trying to crack the mystery of the Fermi paradox for years, and their theories range from the everyday to the truly amazing. Some experts believe that intelligent civilizations might be spread so far apart or lack the technology to send messages over vast distances. Others think that advanced societies might deliberately keep quiet, either to stay hidden or because they're not interested in exploring the universe. One of the most unsettling ideas is the dark forest theory. It suggests that intelligent civilizations might stay hidden out of fear. In a universe where resources are scarce and competition is fierce, revealing oneself could lead to destruction. This theory paints the universe as a dark forest, where every civilization is like a silent hunter, trying not to be seen to survive. The terrifying possibility is that any civilization that makes its presence known could be wiped out by a more advanced and aggressive race. The dark forest theory also assumes that alien civilizations think like humans, focusing on self-preservation and competition. But this might be a mistaken belief. Alien minds could be so different from ours that we might not even recognize their goals or behaviors. They might not think in terms of exploration or communication, making our search for them pointless. Another idea is that humanity might be one of the most advanced civilizations in the galaxy. If other civilizations are less developed or haven't yet reached the technological level needed for space exploration, we might be one of the first to venture beyond our home planet. While this might be a comforting thought, it also suggests that we are alone in the galaxy.